Okay, so I'm on an Apple Mac, so I'm just getting used to things. So what I thought I would do is look at one of the hardest questions that have come up the new GCSE. But before we do that, what it involves is on the non-calc paper 1. So what it involves is these trig ratios that you need to remember. And I don't remember them. I really don't like memorising things. What I like to do is know where they come from. So I'm going to look at 2. I'm going to look at, actually, do you know what? I might change that tan 60. I'm going to look at 2. I'm going to look at sine 45 and tan 30. And I want you to look at how I work these out. The 45s, the 30s, the 60s, and it's for all sine, tan and cos. But we'll just have a look at 2 of them. So the way that I have them is one of the big things that I use with my students, and it doesn't matter if we're doing chem, physics, maths, is the unitary system and the unitary method. And what that means is I look at things all based on the fact that they're 1, as in we start off with the number 1. I like the number 1. Funnily enough, I don't like that right angle triangle, so I don't draw a neat one. So I start off with the number 1. Everything's to do with the number 1 because mathematically it's really easy to deal with. 1 squared is 1. Dividing something by 1 leaves it as 1. Dividing something by 1 doesn't change it, or leaves it as 1. Multiplying something by 1 just doesn't change it. So it's a really nice number to use. So what I'm really going to do here is when I've just I might just alter this one, make it look more like I kind of want it to. I think I'm going to get about that close. So what I have is a right angle triangle here. It's not just a right angle triangle, it's a right angle isosceles triangle. So we're going to look at sine 45. So these two both will be 45. And since it's an isosceles right angle, these two will be the same, so I'll call them 1. Each one is 1 long. So what that tells me is if I want to work out the hypotenuse, I use Pythagoras Theorem. And if these are A, B and C, we end up with 1 squared plus 1 squared equals C squared. I'm just going to remove that there. This is 1 plus 1 equals C squared, 2 equals C squared. So C, which is my hypotenuse, will be taking roots of both sides. This will be root 2. So if I'm going to look at sine 45, I can pick either angle because both of them are 45. So I'm going to pick this one. So sine theta equals opposite of the hypotenuse. In this case, opposite is 1 and hypotenuse is root 2. And so we're looking at sine 45 equals 1 over root 2. Now, depending on my calculation that I'm given, I might leave it like that. But it depends on the kind of calculation I'm given. Normally what I would do is rationalize my denominator. And as cumbersomely awkward as that word sounds, all I'm going to do is square, and yes, I'm squaring the bottom number, I'm timesing it by itself. I'm squaring root 2 by root 2 to give me 2, and if I have a fraction and I want to leave it as an equivalent fraction, I will times my top number by root 2. So sine 45 equals root 2 over 2. That worked for all of them. So I could look at tan 45, cos 45, but I'm not going to. What I am going to look at is tan 30. And I'm just going to write it over here. Tan 30 is a nice one. I'm just going to change colour. I love my pink, but I'm going to change to blue. Tan 30. So this one won't work. So what I'm going to do now is I'm instead of using a right angle triangle, I'm going to use an equilateral. And in this equilateral, I know it's not exactly an equilateral, but we'll make it look like an equilateral. I want to use trig, but this isn't a right angle triangle. So what I'm going to do is I'm going to drop it down here, use a perpendicular. I'll try that again. And I'm going to make the angle at the bottom 90 degrees by making it perpendicular. If I get this drawing nice and neat, it will be good. There you go. Oh, well, it will do. So this is 90 degrees. And I still want to use my unitary method, so I'm going to make this 1. And the reason I'm going to make that 1 is because it's a nice equilateral. That will be 60 degrees. that'll be 60 degrees. So this can be, this bottom line now will be 2, this will be 2, and this will be 2. And what I'm really going to focus on is one of the right angle triangles. So as much as this is in my head, I'm just going to delete this, just so it makes it easy to write on and gives me some space. So the side I've got missing, and I've got 60 here, and I've got 30 here, because I've chopped this angle, this 60 degrees in half. So that's 30 degrees. I've got this side missing. And we're doing tan 30, so tan is opposite over adjacent. My adjacent's missing. We're again going to use Pythagoras. So what I've got here is, I'm going to call this B and this is A. So we've got 1 squared plus B squared equals 2 squared, which we end up with 1 plus B squared equals 4. I want to get rid of this 1. I want my B's by itself. I'm going to root them both. So give me B equals root 3. So here, let's just get rid of this symbol here. B here is root 3. Tan theta is opposite over adjacent. And we're looking at tan 30. Oopsie daisy. Let's get that right. Tan 30. Tan 30 is this angle here, opposite 1 over adjacent root 3. And that's it. It will work for tan 30, sine 30, cos 30, and it will also work for 60s. The 90s and the 90s and the zeros you learn. I'm not going to go through that. But again, when I'm at this point here, I could rationalize my denominator. But again, it looks, if I look at my question, I think, I'm dealing with fractions. And you'll see it in the next question. If I'm looking at fractions where actually having 1 over root 3 helps, I might use 1 over root 3. But if they ask me what's the ratio, I'd rationalise my denominator and come to here. Right, so this is my first video on my apple, so let's just